Geometry, Unit 8, which is Chapter 6 in the book, Section 2, Chord Properties. A chord is a line segment that connects 2 points on a circle. So here we go. BC is a chord. We also have AC being a chord, but AC is also known by another name. Since AC goes through the center of the circle, D, AC is also called the diameter. If two chords are congruent on the same circle, then the minor arc created by the chords are also congruent. So these chords, if they are congruent, the arcs they create are also congruent. That's what it's telling us there. So let's use that knowledge to solve some unknown angles and arcs. So here we go. Let's start with that property we just talked about. Those two chords are congruent, thus these two arcs are congruent. And all the arcs in a circle add up to 360. So it's 360 minus 100, minus 40, minus 100, and we get this arc is 120 degrees. Next, if we remember, this is called a central angle. It's at the center of the circle. It measures the same degrees as the arc. So this is 40 degrees. Then look, same thing happening here. So this is 100 degrees. Now, we actually have an isosceles triangle here because those are radiuses, they're congruent. 180 minus 100 is 80 divided by 2, and those angles are 40 degrees. Now let's look at this next one. Here, we've got tangents intersecting radius. Well, remember, tangents intersecting a radius creates a right angle. So that's 90 degrees. That's 90 degrees. And so what I have highlighted is a quadrilateral, which add up to 360. So 360 minus 90, minus 90, minus 60 is 120 degrees. And then this creates this minor arc. That central angle creates the minor arc. So that's got to be 120 degrees. Well, look, those chords are congruent. So this has also got to be 120 degrees. And then all the arcs in a circle add up to 360. So this arc is also 120 degrees. Another chord property. If the radius intersects the chord at 90 degrees, it bisects the chord and the minor arc. So here, the radius intersects the chord, so it bisects the chord, and it bisects the arc. So remember, bisecting means it cuts into two congruent parts. So let's use that knowledge to solve a couple of problems. Well, here, what we have is a right triangle. That's the hypotenuse, as you see. So a squared plus 3 squared equals c squared. We solve for that and we end up with 4. Now, this full length is the radius, which is the same as this length. So the whole length is 5, but this part is 4, so EF has got to be 1. These are congruent, so EC has got to be 3. Now let's look at this next problem. Here, we've got a right triangle. We know it's right because the tangent intersects the radius at 90 degrees. So that is C, because it's across from the hypotenuse. So we have 12 squared plus a squared equals 13 squared. We solve for a, we end up with 5. Now we end up with this as a triangle. And we know these are congruent, so that's 2.5. So we've got a 30, 60, 90 triangle. We know it's 30, 60, 90 because this side is half of the hypotenuse. Thus, this side is that length, 2.5, times the square root of 3. Now, this length is the radius, which is the same as this, which is 5. So EF is going to be 5 minus 2.5 square root of 3. And that is the end of this lesson.